All right, so we've talked about combining algebraic terms. Combining meaning either add or subtract depending on the sign. We've talked about multiplying algebraic terms. And today what we're going to do is we're going to do the last one, which is dividing algebraic terms. And you often see this written as working with algebraic fractions, because remember that if you have some fraction, that literally means A divided by B. So fractions in algebra, most division is written as a fraction. So that's why you see this as algebraic fractions. But what you can also think of it is as dividing algebraic terms. It means the same thing, because anytime you see that fraction bar, you should think what operation? Divide. There you go. Okay? So what we're going to do is we're going to look at dividing terms, and we're going to think about it in the same way that we've been thinking about everything else, which is thinking about how many parts a term has. How many parts does every term have? 4. And keep that in mind, because it's been the key all along, isn't it? Sign, coefficient, base, and exponent. So make sure that you keep that in mind. So remember, every algebraic term has 4 parts. Think about those as we go. So when you're dividing, first thing you want to do is determine the sign. And again, remember, the rules for determining your sign for division are the same as the rules for what? Multiplication. Excellent. So if the signs are the same, the answer is going to be a what? Positive. If the signs are different, the answer is going to be a what? Negative. Okay? There you go. Keep in mind that the sign is critical to your answer. You must determine the sign. Okay? All right. What's the second part of every term? The coefficient, which is just a fancy word for a multiplier, which means the number in a term. It's always the number. So what you're going to do is you're going to divide the numbers. Now, if possible. Because not every number will divide evenly by every other number. And that is literally how fractions are born. If you have a number that you can't divide by another number, that's how it becomes a fraction. So 5 divided by 3, for example. Can you divide a 5 by a 3? Nope. So we just write it as 5 over 3. So it just stays a fraction. So keep in mind that you're not always going to be able to divide the numbers. Now, some of you are going to be tempted to put the numbers into your calculator and change it to a decimal. I am going to tell you not to. If you start with fractions, unless you are specifically told to change it to a decimal, if you start with a fraction, you must end with a fraction. And the reason for that is fractions are more accurate. If you do 1/3 as a fraction, that's just 1/3. But if you do 1/3 as a decimal, you get all those 3's repeating, so you have to round it. So do you see that fractions are actually more precise? So that's why we like to use them in mathematics. Step 3. What's the third part of every term? The base. And just like with multiplication, you're going to keep the base. Mostly. In other words, most of the times you're going to keep the base, but there will be times when the base disappears. And we'll talk about how that happens in just a moment. Okay? Now, the last part of every term is its what? Fourth part is its exponent. And remember, when we multiplied terms, what did I do to the exponents? Added them. But so when you're dividing, what do you think you're going to do to them? Exactly. Subtract the exponents. And this is where we can get into some trouble. So, when you subtract these exponents, you need to watch out. And we're going to talk about what I mean by that first, right off the bat. Because that's the only thing. The sign, big deal. The coefficient, big deal. But it's the exponents, when you subtract them, that can cause you trouble. Okay? So that's what we want to talk about first. Now, Not all of these things will happen to you at this level, but you need to be prepared just in case. Okay? So let's turn the page. When you subtract exponents, you need to make sure that it's always the exponent in the numerator minus the exponent in the denominator. You have to be going from the top to the bottom. So make sure you get the order right. Because if you don't get the order right, then you're going to come up with the wrong sign for your exponent. Because yes, exponents can have signs because we're subtracting. Okay? So the first thing that can happen is you simply subtract them. Just like always. So that's no big deal. So say we have x to the fifth over x to the third. What operation is indicated by the fraction bar? Divide. Do I have the same base? Yes. So I'm going to keep the base. And what am I going to do to the exponents? Subtract them. So it becomes x to the 5 minus 3, which becomes x to the 2. So that's pretty straightforward. Do you see how I wrote that out? You could do yourself a big favor and write that out every time you do this. Now, I'm not going to insist on it because I can't make you do something that you're not going to do, but I can tell you that if you don't write it out, at least while you're first learning in this, then you will make small errors that lead to huge mistakes. So it doesn't take you any time to write that 5 minus 3. And you're going to see why in just a second. Okay? Sometimes you will get a negative exponent. And let me show you what that looks like. We'll just use the same numbers. Say we have this time x over 3 divided by x over 5. So that becomes x to the 3 minus 5. And what is 3 minus 5 going to leave you? Negative 2. Okay? And a negative exponent is a problem. We can't leave an exponent as being negative. It's not done. What that negative is telling you, the negative means it's in the wrong place. Okay. So it's telling you that if it's in the numerator, it should be in the denominator. If it's negative in the denominator, it should be in the numerator. Okay? So what that negative is telling you is that it's in the wrong place. And if you look at our original fraction, you can see why. Look at x to the third and x to the fifth. Which one is bigger? X to the fifth. And where is it? In the bottom, in the denominator. That tells me my x's should end up in the denominator because there are more of them down there. Yeah? So, and that's what happens when we use the shortcut. That's how we end up with these negative exponents. But it's easy to take care of. All I'm going to do is simply move the base and its exponent. So simply move the base and the exponent across the fraction bar. Put it in the right spot. If it's in the wrong spot, just move it and put it in the right spot. And when you do that, the exponent's not negative anymore. Okay? So the exponent becomes positive when you do that. Because you put it in the right spot. Okay? Okay. So, say for example, like earlier, there was a student in the wrong classroom. How do I correct that? Put them in the right classroom. Do they change? Because they're just in the right spot now, right? Before they were in the wrong spot. And that's all the negative is telling you. There's nothing mathematical about it. Don't worry about doing any math. you just put it in the right spot, and that means you don't need to say it's in the wrong spot anymore. Okay? So, if you look at x to the minus 2 there, does it look like a fraction right now? No, which tells you that it's in the numerator, because anything is a fraction, right? It's really in the numerator there, so you can think of it as something over 1, but don't even worry about that. So where should it be then? In the denominator, where it becomes x to the 2 like it's supposed to be. But I don't have anything left in the numerator. But there was a number in front of this x squared. What was it?
1.
So that 1 is always there. So x to the negative 2 simply becomes 1 over x to the second. Now, if you had another number there, then that number would stay there. So let's say you had 3y to the negative second. Which thing is in the wrong space? The 3? No. Which thing? The y to the second. It shouldn't be in the top. It should be in the bottom. And so that means my 3 is going to stay in the top. It didn't have a negative exponent, so it doesn't move. Only the thing with the negative exponent moves. And of course, when you move it, it simply changes the sign, because it's where it's supposed to be. Make sense? And that can happen to you quite a lot when you're subtracting these. Anytime you subtract a big number from a small number, you're going to get a negative, so you're going to have to fix it. Okay? Good. Third thing that can happen to you, and this one is going to look a little odd, but in your study of exponents, somewhere, hopefully you've seen these, but if not, don't worry about it. The third thing that can happen to you is you can subtract an exponent from itself. Let me show you what I mean. We have x to the 5th divided by x to the 5th. So what operation is indicated by the fraction bar? Division. So we get x to the 5 minus 5. And what number do you get when you subtract something from itself? 0. So that gives you x to the 0 power. Do you agree? Okay. So it gives an exponent, an exponent of 0. Does anybody remember, have you ever learned maybe what an exponent of 0 means? That it's 1. Excellent. Good job. Most people want to think of it 0, but it's not. So x to the 0, or anything to the 0, always equals 1. And I'm going to show you why, and it makes perfect sense. Anything to the 0 power, and remember, power is just another word for exponent or index, equals 1, no matter what. And that makes perfect sense if you'll just go back up to the division in the beginning. The reason this became a 0 is because x to the 5th divided by x to the 5th is something divided by itself, isn't it? And anything divided by itself has to equal what number? 1. Doesn't matter what it is. Anything divided by itself always equals 1. So if you get a 0 power, what that literally means is you were dividing something by itself. And that gives you the 0 power. And that's why it has to equal 1. Because anything divided by itself, no matter how big or how small, always equals 1. Okay? So, 3 things that can happen to you. 7 minus 2, I get an exponent of 5. Who cares? Perfect. Who cares? Right? 2 minus 7, I get an exponent of negative 5. That tells me it shouldn't be in the numerator. I need to do what? Drop it to the denominator, right? Where it becomes positive. 7 minus 7 gives me x to the 0, which turns into a 1. Okay? So those are the 3 things that can happen to you. Mm-hmm. Just 1. The whole x turns into a 1. Mm-hmm. Yeah, it's not the exponent. It's just the whole thing turns into a 1. Okay, and so that's the only twist, because otherwise we're just dividing, so we use the sign rules, divide the numbers just like we always have, etc. Now you're going to see some notation changes too, and we'll talk about those a little bit. If you have, let's say, so just think about these notations. If I have x over 2, what number is in front of that x? A 1. So that's the same thing as saying 1/2 times x. Okay? So you can drop the x off to the side, and that's generally what we like to do, is we like to have our number, even if that number is a fraction, we like to have it in front. We don't like our variables to be in fractions if we can avoid it. And you can avoid it by just dropping it off to the side. So say, for example, we have 3x over 5. How can I write that? Well, 3 over 5, and then the x just goes off to the side. Okay, so 3/5 x. Okay, now, that's only when the x is in the top, though. So be careful. If the x is in the bottom, that means I'm dividing by x. That's something totally different. So you'll just leave it alone. Okay? But if the x is in the top, we like to write it on the side instead. Okay? And again, it's just a matter of notation. It means the same thing. Because 3x literally means 3 times x, right? So it's 3 times x over 5, which is the same as 3 over 5 times x, which is the same as 3 over 5 crammed together with x. So it's just notation. You'll get used to it. It's just part of algebra to think about the notations. Because you're going to usually see this, not this. Okay? Technically it doesn't matter, but you need to be aware. And this is the better form, having the x off to the side. Okay? So what we're going to do is we're going to go to your book and we're just going to look at a bunch of these, and then you're going to perform some of these operations. And then there's a second part of this. We're going to have two sections we're going to do today. First, we're going to look at the division, and the second part is there's some division and multiplication combined. So you have to make sure you know which rule's which. Those are the ones that are super valuable because it really makes you think about what you're doing. Okay? So keep that in mind as we go.